So welcome back everyone to the first Cybersecurity Magazine podcast of 2022. I'm Philippa Jefferies and I'm joined by Hans-Christian Rudolph as always, and today we are talking to Peter Langendörfer from the Leibniz Institute for High Performance Microelectronics about his work in AI detection of attacks in automation systems. So welcome everyone. To start with, Peter, can you please briefly introduce your work in this area and yourself?
Thank you, Philippa, and welcome everyone. Yes, sure. So automation systems are all the systems that are going to control some kind of a process, which might be factory floor automation, like producing cars, but also chemical processes. And it might relate also to critical infrastructure as energy grid or waterworks. And of course, the problem is that most of these systems are deployed and are working for several decades, which is definitely decoupled from the lifetime of consumables, where we have something like a 2-year cycle, and then you get a new device, and here we have like 20, 15 years, which means in some cases the software is outdated, no one is providing some kind of patches any longer, and the devices might be now connected to the internet because running the devices using wireless connections and using the internet is going to help the businesses to improve the process in the sense of reducing cost to do so. But the devices are now exposed to all the attacks that are done for internet-enabled devices, but they haven't been thought to be connected to the internet when they were developed first. So this is where the big problem comes from. And talking about AI in that field, we have the problem that we need to detect some of the attacks as early as possible. And in the last millennium, AI-based intrusion detection was considered to be infeasible, which may be related to the fact that the processing power to do strong learning with machine learning algorithms was not really available. So they really advanced in that field. And in addition, when it comes to automation systems, it's not like you have a very creative user in front of a desktop device doing something new, and you have that the impression that this is kind of an anomaly. But in a manufacturing system, it's quite regular, so you know exactly when the machinery is going to communicate, when sensor readings are done, when are they sent to the control station, stuff like that. So it seems at least to be much easier to learn what the normal behavior is and then to detect the anomalous behavior in order to say, okay, this or that is kind of an attack. If it's an attack, you eventually don't know that for sure, because it might be just a device that is malfunctioning due to aging or whatever. But in my point of view, this is not that bad. So you have a false positive with respect to the security issue, but there is some problem you need to care about in any case. So that should be not that bad and not make the system unusable. So.
Okay, fantastic. And kind of going back to automation systems themselves, you talked a little bit about how it can be a challenge because they can become connected to an internet or have outdated software on them. I was just wondering if we could talk a bit more about specifically kind of what security risks are associated with automation systems. Kind of what kind of attacks would you expect, and what kind of attacks are you looking at?
So simple attacks might be denial of service attacks, when you just make sure that there is more network traffic than the system can handle. Which is quite easy to do. And then if the communication of the automation system is cut, it might run into a state in which it's no longer under control or just go into some kind of emergency stop.
Okay.
Talking about critical infrastructure like waterworks, you definitely don't want to have something like that. I'm talking about waterworks. So last year, February, there was an attack against the waterworks in Oldsmar, Florida, where they were trying to increase the percentage of, I think it was nitrate or nitrite or something like that, which is normally used to clean the water. But if you increase it above a certain threshold, it becomes poisoning to the people consuming water. So it was detected very early, but this was the last very prominent attack against automation systems.
Would you say that kind of automating systems more opens them up more to attacks and makes them more vulnerable in this way? Or is it kind of like they're just more vulnerable to different types of attacks?
To be honest, I don't really understand what is the difference in the two things you are asking for. So I try to answer both. So automation systems are vulnerable to different type of attacks, definitely. So denial of service, as already mentioned, is something that can be run against any network system. So with a distributed denial of service attack, you can even get down the Amazon server farm.
Yeah.
And you can do it for automation systems. We just published a new attack against an automation system in which we were manipulating the code executed by the programmable logic controller, which puts it into a hold state to a date we defined, which means you can determine at which point in time the system is going to stop working properly. And you can do that well in advance, so you don't have any problem with the timing to get into the system. So you can do everything with sufficient time, and then you just define the time when the attack strikes. And I think this is a bit different to what you normally have in a computer system, even though some of the ransomware stuff is doing similar things. So they infect your system and they start working only a few days, weeks, or even months later. And then they are going to encrypt your system and send you the letter to pay for. So in principle, there are very, very much similarities, but the consequences might be completely different. So automation systems going wild may cause harm to human being lives. And as long as it is not the hospital infected by the ransomware, it normally does not mean a direct consequence for the safety of people. I think this is more or less the difference I would make. So at the end, it's all a network system and it's vulnerable to all that. And what I often hear from small and medium enterprises, we're too small to be attacked, which is not really true. There are some search engines in the web, which is one is Shodan. It's like Google for IoT devices. You can look up for PLCs. You can even look up for devices with specific vulnerabilities. You can even look for servers still having the heartbleed bug, and you can definitely go for those. Which does not mean that you're attacking an SME directly, a specific one, but you can go for any. Or if it's like the watering hole attacks, you just send out phishing mails where the devices are infected. And then you just hit some of the SMEs who never thought to be on your list, just by pure random.
Right. Thank you for that introduction, Peter. Now that we've established sort of a basis of what we want to protect and what we want to protect against, want to move our focus a little bit to the how and what your research is focusing on in terms of detection of attacks. So what exactly do we mean when we say AI detection or AI-supported detection of attacks against these systems?
Okay, so basically the idea is quite simple, where we try to record some of the normal behavior once the system is in place, and try to use AI means in order to do kind of a classification, what is the normal behavior, and then anything that does not match that class is considered to be some kind of anomaly, which then may be considered to be an attack. So in principle, we are mainly going for something called a one-class classifier. And one of the most simple methods are support vector machines, which is good because with automation systems, we also talk about resource-constrained devices. So most of these devices don't have many resources in the sense of computing power, so you can do only very simple things.
Okay.
Right. Also, that is not going to run on the PLCs, but somewhere else in the network, because you need to know a bit more about the network traffic to see if there is something fishy going on. Is that more or less answering your question?
Yeah, that gives us an idea, and maybe to provide our listeners with a bit more context of where we're coming from in this domain. You mentioned earlier that in the early 90s or in the 90s and the early 2000s, that type of detection was considered to be too complex. What exactly has been done before, or is this kind of attack detection completely new in the domain of automation systems?
I think in the past, nobody was caring about detecting attacks in automation systems. So they have been really sloppy also with just making sure that they have the last patches deployed. So I think the first serious attack against an automation system was an attack which was done by pure random against a nuclear plant in the US. I think it was in Ohio in 2001. And they were hit by the slammer worm, which was not definitely done to run an attack against automation systems. It was just overloading the whole internet all over the world. And the patches against the slammer worm were out 6 months before that attack happened. And I think it was a subcontractor doing some construction work there, and they came with an infected device, and this device was infecting the nuclear plant. And even though nothing bad happened, I don't consider that a relaxing situation. And I also think that the well-known Stuxnet could have been eventually detected earlier if there would have been a proper supervision or monitoring of the network traffic, because it was crawling through the automation network to find the right devices. And most probably that happened at points in time where there should not have been any type of communication at all. So it would have been kind of an indication. So I think with respect to that, so it's quite new that they are caring about that, which is also related to the fact that they haven't been networked that much in the past.
Okay, and kind of, yeah, looking again at kind of using specifically artificial intelligence for security, what benefits would you say that AI-supported detection brings to automation systems opposed to kind of other methods of security?
I think the benefits are that you may be able to detect kind of, I would call it a zero-day exploit or very new attack, because if you have a signature-based system, you need to know in which steps the attack is going to happen, how the packets are going to look like, and then you record, okay, this looks like step 1, step 2, step 3, okay, this is an attack.
Yeah.
But that means you need to know the attack. If someone comes with something completely new, you won't be able to do it with such kind of a system. And the AI-based stuff has the benefit that you eventually are going to see that there are some differences from the normal behavior, so that you can detect this type of attacks early. But that holds true also for the non-automation systems like on the internet. We are looking for automation systems because they come with this extra feature or extra challenge that you need to do it for resource-constrained systems that are outdated. So you could do it for any other system as well. And I think the AI-based stuff is now running also quite well.
Okay, and I was just wondering, you mentioned earlier that the AI may detect not just kind of attacks or malicious attacks, but also kind of issues within the system that appear like someone's interfering. I was just wondering if there's a way that you can tell kind of what is a real attack and what is just an issue in the system, and whether AI can do that?
I would say in principle, yes, it's feasible. At the end, it really depends on the training data you have at hand.
Okay.
So after a while, if you have sufficient traces, what happens in case of a failure of some of the systems, like a sensor or valves or whatever, you can have the AI means trained to detect different types of anomalies. So that you no longer go for one class classifier and normal behavior anomalies, but you go for normal behavior, problems with a sensor, problems with valves, attacks. That's feasible. But the tricky thing is to get sufficient data to do proper training. Make sure that this data is available is eventually really tricky for companies that do not own such large systems. And this is part of what we're trying to research right now with experts from the field of AI, how we are able, or if we are able to merge the data of different waterworks in order to make sure that at the end the trained system can be applied for different types of waterworks. So they should be very similar. So in principle, it seems feasible. But it needs to be proven that that works. We're trying to do so also with simulation data in order to enhance the training data set, to get more training traces, because this is what makes the quality at the end more sustainable.
That makes sense. Yeah, that would have been one of my next questions. So is how well does it translate to different systems? You mentioned that, you mentioned earlier that obviously you are working in a very resource-constrained environment. Are there any other very specific challenges when applying AI specifically to this domain or to this type of system?
Honestly, I don't think so. So the problem are the resources in sense of training data and computing resources. And the other thing is that because this is a real-time system, if you want to intervene once you detected an attack, it's not that easy because eventually you cannot really stop the process for different reasons. If it's a chemical process, it won't stop immediately. That's the one thing. If it's critical infrastructure and there is an attack going on, so if you stop the waterworks from providing drinking water to your population, you might be in trouble as well. So eventually it's better to let the attack run and try to cure it in a different way. And also the point of doing the monitoring may not interfere with the normal operation. So talking about real time means some deterministic behavior. So it's not essentially needed that it's really fast, but if you kind of disturb the system by hopefully only passive reading, it shouldn't happen. But if you do something in addition, in the sense of we apply some cryptographic means to make sure that the messages have their integrity entered, then it might become really tricky to really apply that. And of course, most of the companies are quite conservative when it comes to touching the system. So also in the project with the waterworks, they were not really happy to do a live demo. So at the end, it will be something which runs in parallel to the system, so that we can show in principle it works, but they won't let you touch the system unless it's in a hold state anyway. Then eventually yes, but for sure not in a normal working situation. And of course, there are some special rules that apply. So normally they are more or less locked in the contract with their automation system supplier. So if they change something with respect to the software and it's not agreed with the vendor, they're going to lose warranty, which is a problem. And if they are not going to support anything new, they are in problem. You normally have not IT specialists there, but some guys from mechanical engineering or automation control engineering with a different mindset and a completely different focus on what is important for the system. So also to raise a proper awareness of the problem and how to treat it is different now if you talk to IT guys.
Okay. Interesting. And kind of going back to looking again at the AI, kind of the benefits it can bring. I was wondering what kind of attacks are particularly kind of appropriate and easy to detect with the help of AI. Is there particular attacks that are kind of more suited to this, or yeah, that was my question.
The honest answer is I really don't dare to say this type of attack is more easy to detect than the other one. For the denial of service attacks, it's quite easy. You see the number of packets increasing. That should be an early indicator. That is easy to do. When it comes to the attack I was mentioning earlier, where we are going to infect really the controller, it's just one more packet, if at all, which is normally exchanged. So there is not much of a difference to be seen. So it really depends on the impact of the attack on the behavior of the system, how good or bad it can be detected using the AI means.
Okay.
On that note, actually, to what extent, based on your research and your interaction with these companies that operate these environments, how well do they enforce basic security hygiene? So, for example, encryption of network traffic, and does that affect the analysis that you're trying to perform using AI?
My current experience is that there is no network traffic encryption at all, at least not once we are in the operation technology, so in the automation system, because the devices are not going to support that. So there are some not that well implemented means in the latest Siemens protocols, where they are trying to have some data integrity, but it's not done on a per packet basis, but more on they do it at the first instance when they set up the connection, and then it runs without kind of refreshing it, which is the reason why our attack infecting the controller even works with the Siemens devices of the latest generation. Which is not much of a relaxing situation. So I understand that running proper cryptographic means on those devices is really, really tricky. And this is the reason why we have invested quite some effort in the past to implement hardware accelerators to do so, because they do not need much energy and they are that fast that they should not make any trouble in a real-time system. But currently the devices are built without this type of hardware accelerators, which is a bit strange because almost all of the wireless devices you can buy at least come with some AES hardware accelerators. So it's implemented in almost any RF front end. And to me, it's not reasonable to set up a device which is communicating even in a wired system without at least that. And that would be a means to get rid of most of the problems, but it's not in place yet. And of course, all the recommendations are there to make sure that you are going to have your network separated. So you have your office network and you have the manufacturing network, and you have a demilitarized zone in between. And in the best case, you allow only communication from the manufacturing side to the office network, but not vice versa. And you're going to rely on specific protocols. You make sure that you have a proper firewall running in the demilitarized zone. Make sure that you detect almost everything. If they are really going to do so, I doubt. And of course, it will depend on the size of the company. So if you have some really large manufacturer, they have their IT specialists hopefully in place, and they will make sure that this is done properly. But if you have an SME with something like 50 employees, they have the similar problems, but they don't have any IT specialists, and it looks like a mess. So we're currently running a competence center for IT security with a focus on the manufacturing systems. And we use a Fischer Technik, it's German, so it's a Fischer Technik system, which looks like a production line. And there we have a Siemens PLC attached to, and we did a first training with some interested guys from SMEs in the region to tell them how to do a network separation in the automation system. And they were quite happy with getting this hands-on experience. So that's kind of a real benefit to them, because they even don't need to pay for the training. So it's funded by the government. So we do that for free. And hopefully we are going to train them in a way that they are able to do that also in the real system.
Okay, great. And just to kind of finish looking at the AI side of it, we were wondering what your view on the kind of risk of hackers or attackers using AI themselves for malicious purposes or to attack the system.
I guess this is going to happen anytime soon. I don't have a clear view how you could use it in order to run a specific type of attack. Okay. First papers are out where people are discussing what is going to happen if you manipulate the training data in order to make sure that some attacks eventually are not going to be detected.
Okay.
This is going to happen in your case when you don't have sufficient data on your own and you need to buy some data to train your system. Otherwise, you should be quite sure that your system is kind of okay. That could be one of the steps to not really exploit the AI power, but to kind of manipulate the AI means in order to do something bad. On the other hand, I already mentioned the hardware accelerators for cryptographic operations. And these devices are eventually vulnerable to something called a side channel attack, which is measuring some of the physical parameters like power traces or electromagnetic traces, and then analyzing that in order to extract the secret key out of the device. And we used AI means to do this extraction from the traces, and that works quite good. It works also well with standard statistical means, because you just need to make sure that you kind of learn what the system is going to do when it's going to process a 1 out of the key or a 0 out of the key. And then you just separate that, but AI means are quite good in doing so. And of course, this is going to be a first step, using AI to really create some sophisticated attacks. We will try to use AI means in the engineering process of these devices to avoid these problems. But,
okay.
This is just a project idea. We applied for a grant, so we will see if we get the money to do so.
I guess to a certain extent, it also is the question of whether you really need AI to attack these systems if basic security hygiene is not implemented throughout. So that's
the problem. So you don't need to have these high-end weapons if they are overwhelmed with just a jackknife. So
right.
Definitely. So it's really tricky to make sure that the world becomes better with respect to that. But I think it's really important that companies start to work on that. And from my experience, it's often that they are kind of biased by the idea that 100% security is so tricky and you never reach it. And due to that we just don't do anything. But I think you can get rid of, I would say, at least 80% of the attacks and issues if you just implement the very basic means.
Okay.
And they're not that tricky. And eventually the percentage is even higher. So they need to start thinking in a different way. That's my opinion, but you never know if I'm right or not. Some basic hygiene would be very well appreciated.
Yeah, definitely. And I'm afraid we're kind of coming to the end of our time now, but just to finish, can you give us some of your thoughts on kind of the future of this research and what kind of your group is looking to do next?
Yeah, sure. So, of course, the AI means are power hungry in the sense of computing intensive. Part of what we're right now doing is to implement some hardware accelerators to use it for detecting attacks. We have a project running in that respect already. So we try to implement a support vector machine and hardware to detect return-oriented programming attacks on embedded devices. So it's a bit different to what we have discussed so far, because that was related more to network. This is really when the malicious software is already more or less deployed on your device. And I think this is the way we are going to proceed. So it will be energy efficient AI means to protect embedded devices, and that might be in the manufacturing area or sensor networks, monitoring environmental processes, stuff like that. And also AI means as a powerful method to improve the quality of such systems will be part of what we are aiming for. And I think more and more groups will go in a similar direction. So my gut feeling.
Great. Well, thank you very much. Thank you so much, Peter, for joining us today and taking the time. It's been really interesting.
Thank you, Philippa. My pleasure. Thank you, Hans.
Thank you.